this is going to be a special episode because we have got a roundtable between Mike Israetel, who you guys should hopefully all know, and also Greg Nuckols, who a lot of you will know as well, who I've been hounding to get on the show. So I have the absolute pleasure to be interviewing the both of them. I do quickly want to introduce them both because we may be getting some new listeners because we have a wider audience due to it being a roundtable. The roundtable is on genetics, so the genetics of bodybuilding, powerlifting, getting strong and big. So Greg is a coach, as you all know, and hopefully know his website as well, so Stronger by Science. And he's written for loads of major publications. He's also got over a decade of experience under the bar and has a BS in exercise and sports science. He has 3-time all-time powerlifting records and coaches kind of regular guys and also really, really strong guys. And hopefully you've recently heard of Mass, which has been released by Greg, Mike Zordos, and Eric Helms, which is a monthly research review specifically aimed at strength and physique sports, which is awesome. Me and Pascal of Revive Stronger are subscribed to this ourselves. So that's Greg, and of course Mike, who used to be the professor of exercise science at Temple University, but has recently left there to focus on Renaissance periodization. He is incredibly intelligent, a very, very strong and humble guy as well, and recently competing and doing very well in bodybuilding for his own right, but also does his own hand at BJJ, which he incorporates with his bodybuilding training. He's also worked alongside and continues to work alongside Juggernaut Training Systems, but most of his time now is spent on podcasts with Renaissance Periodization and Renaissance Plus, which is fantastic, working on ebooks, obviously on Facebook, and traveling, doing cool seminars. So that is a brief introduction to both Greg and Mike. I hope you enjoy this first little kind of taster into the roundtable. We will be having future episodes that you can look forward to. So cheers, guys. Enjoy the episode. We will first be going over something that I find really interesting with this topic of genetics is the fact that we know that 99.9% of our genetics are similar. So how much of an impact can genetics really have on our potential strength and muscle gains? Whether or not that's actually a true fact, are our genetics 99.9% the same? I know Mike has talked about how, and in the pyramid of strength training, individualization is like the last thing to be looking at. I would like to hear your guys' thoughts on this, and yeah, just we'll open the floor with that if that's okay. And I don't know if either one of you want to particularly take this one. Feel free to go for it, or yeah, we can chuck it around.
Do you want to take this first, Mike?
Yeah, sure. See what you can add to it or subtract from it. So to take all the 3 major human races together, even that much genetic difference amounts to less than 1% by a long shot difference in total genes. So it's very small. But when we say that it's a very small difference, there's still within the human populations a considerable amount of potential for different appearances and responses, especially in magnitudes, not in qualities. Because so it's more than 99% similar sounds super similar. But if you look at what most genes are coding, it's sort of basic functions that we take completely for granted in most animals. For example, from my memory, a laboratory mouse has about 92% the same genes as a human. Now, you think, holy shit, how's that possible? Well, it has 4 limbs. It has a heart, has lungs, has a liver, has the same fundamental molecular machinery. I mean, that's the stuff that takes most of your DNA to code, not unsurprisingly, because that shit is super complicated. Like what color your skin is and how much muscle you grow per year is much simpler. It's a magnitude scale as opposed to a qualitative scale. The genes that engineer your heart. It's quite a gene complex there. So, there is a small genetic difference between all humans. So we can say that all humans respond to stressors in more or less the same way. All humans digest food in more or less the same way. But the degrees to which they do it tend to be different. And when you have especially multifactorial situations, like for example, how much testosterone are you secreting? How responsive are you to testosterone? You may not secrete much more testosterone, much less than somebody else. and your responsiveness might be not much more or less, but you factor those two together, you multiply them together, and all of a sudden you have someone who's a hyper secretor of testosterone, maybe only double the normal testosterone, and you have someone who's twice as sensitive to testosterone at the level of a muscle cell. Then 2 times 2, that's 4, and now they're 4 times more anabolic potentially than someone who has the other side of the equation, or the other side of the spectrum for both. And then, so factors that genetically produce muscle growth, their number at least in the 10 major pathways. And if you are extreme in all 10, you can imagine that you're going to leave people behind, and thus the genetic proclivity for muscle growth or lack thereof, strength, lack thereof, et cetera. And there's different proclivity, which Greg can speak to, initial starting rates and adaptive proclivity, how much you actually adapt from training. Then we start getting into genetics being very considerably complex and being able to say a lot about the magnitude difference between adaptations. At the end of the day, yeah, genetics plays a big role in how far you go and where you start. I think more practical examples, Greg can probably take it from here.
Yeah, and just one other thing I'd add about the 99.9% similar point. So that tells you like the number of genes that we share, but not necessarily like the types of genes we share. So, for example, take something like the ACTN3 gene, which codes for actinin, which is a protein in your muscles that essentially allows your fast twitch fibers to be more explosive than your slow twitch fibers. There's a version of that gene that codes for a protein that basically does what it's supposed to do. And there's a version of that gene that codes for a crappy protein that doesn't really do what it's supposed to do. And you look at someone that has the correct version of that gene versus the incorrect version of that gene. They both have that same gene. So that would be counted in the 99.9% genetic similarity. But because they have different versions of that gene, that leads to a phenotypic. And something else where you can have the same genes but also different responses is something called copy number variation. So most people probably learned in high school biology that you have 2 alleles for each gene, one on the chromosome you got from your mom, one on the chromosome you got from your dad. You have 2 copies of each gene. That's actually not true. You do have 2 copies of most genes, but you can have many more than 2 copies. So there was a study looking at salivary amylase gene, so a gene that codes for the enzyme amylase in your saliva that lets you start breaking down starch in your mouth. And basically, salivary amylase predicts to some degree how much intrinsic reward you'll get from eating starchy foods, because you can break more of that down in your mouth. It tastes sweeter. It's just generally a more rewarding experience. And they found that, so a paper published in Nature, I believe, 2 years ago, found that people that had more copies of the salivary amylase gene had higher levels of salivary amylase, and therefore they could break down more starch in their mouth, got a larger reward response from any amount of starch they ate, and were consequently leaner than people that had fewer copies of the salivary amylase gene, because they didn't have to eat as much starch to get as much intrinsic reward from eating it. So yeah, that's another example of all of the people in that study had the same gene. They had the salivary amylase gene, but the number of copies they had of that gene, again, influenced phenotypic responses, but it would still be counted in that 99.9% of genetic similarity. So yeah, essentially that's 99.9% the same. That's misleadingly high. Like Mike said, the vast majority of those genes are coding for stuff that is going on. All of them are producing proteins on a microscopic scale, but most of them, their effects don't really leave kind of the cellular level. And there's a lot of stuff that has to go on in your body or a mouse's body or a fruit fly's body where something like 70-something% genetically similar to a fruit fly, but obviously we're much more than 30% phenotypically different from a fruit fly.
I don't know, Jeff Goldblum, especially in the movie The Fly. But go on.
But yeah, so there's several different avenues by which you can share basically all of the same genes, but still wind up with very, very different outcomes.
I think that's super interesting. And I think it completely is misleading. And I think a lot of people hear it and they think, oh, like then it just all comes down to hard work, which we will get onto. And I think, I don't know, there's a similar or a analogy I could think of.
I mean, on an individual level, it definitely all comes down to hard work. But when comparing multiple individuals, it definitely has to do with a lot more than just hard work.
By the way, hard work is at least a 50% genetic explanatory factor. That's neither here nor there. I don't think we want to open up that can of worms today.
Oh, maybe we do. I was just going to say the analogy, something like just like personal trainers. There's a lot of personal trainers, and you could say like they're 99.9% the same, but then there's a lot of differences between personal trainers or something along those lines. People can think of that sort of thing like it's the same job, but there's so many differences within that.
They both put on clothes. They both come in on time. They both train clients. They both use weights. So like to an untrained person, all personal trainers look the same. To someone who never goes to the gym, but to someone like to an alien, you know, like a lot of animals on Earth that look the fucking same. Like, you know, so for example, one of the things about genetics, if you take a look at raccoons, you know, your human eye is designed to derive individual humans exceptionally well. It is not designed to derive individual other animals exceptionally well. Like, can you tell raccoons apart? Like, you see one raccoon in your neighborhood, you see another, you're like, that's that motherfucker that went in my garbage. I know him. I know that face. You can't tell them apart, but they're wildly. This genetic variation in most animals is much higher than it is within the human subpopulation. So it's one of those situations where it's like, so just because you can't tell it apart maybe means you're not keen to the differences. But when you start really paying attention, the differences can be impactful precisely in the ways also that only interest us kind of like muscle nerds, right? Like, so if you tell someone, like, well, humans are quite different, you see, and they're like, well, how's that? And you're like, well, I know we all have 2 eyes and 2 ears and shit like that, but some of us grow muscle much faster than others. And to a person not in the industry, to be like, so fucking what? We're like, well, but you see, that's the big part of life. Doesn't that make sense? They're like, no. We're like, all right, well, never mind. I guess it's not a big difference. But to us, it's a curious difference for sure. So.
Awesome. And well, the model I was actually going to bring up was Lyle McDonald. I don't know if you've seen this model he actually made. It had like work at the top, had talent on the side, and it had high and low for each. And then for someone who was like high at working and high at talent, they were a thoroughbred. Then there's someone who was a high worker but had low talent, were a workhorse. And then someone who had low talent and low work, were the always gunner, so someone who really just tries. And then someone who has high talent but low work ethic were the prima donna. And do you see that as like a representation of what people could potentially see? Like, are people that like easily segmented, or is that, like you said, is that opening a can of worms? And because like your work ethic is actually almost part of your talent.
Greg, you want to take this one first, or you want me to start on it?
I haven't seen the model, so I wouldn't be comfortable commenting on it too much. But I think what I would say in general is that those classifications might hold at like the very far corners of that little box that they would make. But it definitely. So I think the biggest thing to keep in mind when we talk about genetics and innate variability between people is all of these things tend to be dispersed on bell curves, and odds are you're not an outlier. Like, most people have similar proclivities to work hard. Most people have similar proclivities for getting bigger and stronger. There are certainly some people who are just absolutely cursed. They can probably still make some gains, but they'll be very, very underwhelming. And then there's some people who are excessively blessed and really don't have to do much of anything. And like, they just look at a weight and get big and strong. So like, definitely on the extremes, crazy stuff can happen. But I think that, the majority of people would be somewhere like where those 4 quadrants intersect, and maybe would skew slightly more one direction or another. But really, for the majority of people, the majority of people are going to be more similar than different. And I think genetics kind of only start getting interesting when you start dealing with freaky people on either end of the spectrum.
Very cool. Mike, is there anything you wanted to add to that?
That pretty much said it all. These are spectrum variables, so to say you can group them. Grouping them into two extremes is very interesting as far as intellectual exercise, and it can really sort of derive some clarity as to why things happen the way they do. But when you go back into real world application, you're going to have individuals that are prone to some extent in a degree 1 through 10, really fractional degrees between that, of work proclivity, of genetics for muscle size, and there's other genetics for fat size, fat distribution, muscle shape, et cetera, et cetera. Not all of us, when we get a certain level of muscularity, end up looking like Jared Feather. Fuck that guy. But anyway, I make sure to insult him at least once. So, but in any case, there's tons of variables that intersect. I think at a fundamental level, I think, whatever genetics you do have, it's probably a good idea to, it's quite simple. You have the genetics you have, and then you have a variety, a sort of a spectrum of potential input you can put into the process of deriving high amounts of muscle growth or strength or whatever. And it's a personal value judgment on your part as to how much you want to input into the process. The interesting thing, and I think Greg can probably talk about this much more, is that there is a little bit of mystery to it because initial conditions they're somewhat predictive of final states and adaptation proclivities for muscle gain and strength gain, but they're not as telling as you would expect. So the person that was the most jacked not lifting weights in high school may not be the person that's the most jacked if everyone in your high school starts lifting weights. Some guy who maybe didn't look all that big is just going to have this gnarly adaptation genetics and just keep fucking growing 10 pounds of muscle every year unabated for fuck knows until he's like Big Rainy or something like that. So some people, I think, have a tendency to sort of lay out their genetics or what their view of genetics is a bit early in the process, maybe at day 1 or month 1, and they go on the forums and they realize they don't look like Mr. Olympia yet. And they'll say, well, man, shit, I'm not going to allocate as many resources as I was planning on originally because clearly I'm not going to be very good. And the funny thing is that it's a bit early to say that sort of thing. So I don't know, Greg probably has some better recommendations. I'd like to hear his take on that. But I think giving it maybe 2 to 4 years of pretty diligent training and pretty decent food and programming and stuff, consistency. After I think 2 to 4 years, you kind of start to figure out which way the cookie crumbles for you, potentially, at least to some extent. Now, there's some stuff with satellite cell number, which you don't run out of those shits until you get into like 5+ years of training or 10 years. You don't really start to milk out the rest of those. So I think some of the curves are mysterious until then, because you might grow amazingly your first 2 to 4 years, but that shit slows down like crazy, or it doesn't slow down. But I think giving it a good old college try is good because you can't quite tell from initial conditions with super good accuracy if you're the man with a plan or not. Right? Greg, what do you think?
Yeah, as far as I'm aware, every time it's been like actually studied, and actually I'll note it's not just like strength and hypertrophy; it's also like aerobic adaptation as well.
Everything actually.
Yeah. So when looking at like VO2 max, lactate threshold, muscle size, measures of strength, and studies that either look at correlations between starting points and percent increases with training, or studies that group by responsiveness. So kind of like post hoc sorting out high versus low responders and seeing were those groups different when they started training? Like, is that something that predicted the differential response? Literally all of the studies that have looked at that, as far as I'm aware, have found that there's no relationship whatsoever between starting point and trainability. So just if people want to look up some examples, I know they made note of that in Evolve 2005. They specifically looked at that in Davidson 2014, and Estrella and Bannon 2007. I can send you links, Steve, if you just want to put them in the show notes. But yeah, that's something that strangely like gets a lot of pushback, and in my experience, it's a lot of pushback from people who have been training for a while and started out kind of small and then ended up getting big and strong. Because these people kind of get this complex where, I was 130 pounds and now I'm like big and strong and jacked. Like, obviously I had terrible genetics to start with, but I still did something with them. So I must work way harder and be way smarter about training than everyone else. And yeah, they may have had crappy like baseline muscle genetics for just how much muscle they carry around if they did absolutely nothing. But that isn't at all predictive of their genetics for adaptation to training.
I think that's super interesting. The fact that some people can kind of, they pick up a dumbbell and they grow really quick, but then they might not grow much more after that, for example. Whereas other people will grow slowly and just kind of trickle along, gaining for longer. And both might have actually good genetics or equally good genetics. And it just comes down to the fact who's actually being consistent and adhering longer term. And I think that's a really nice thing for a lot of the listeners who maybe feel like they have those poorer genetics. For myself, I know like when I first got into lifting, I was like, why am I not big and jacked and like as big as these guys yet? But after time, like I'm looking now and I'm like, oh, actually I have like a respectable physique. And it's like, well, I used to think I had bad genetics. Potentially, actually, it was just like you're a late bloomer, as it were. So I think that's really interesting. Something the listeners, and some of them might not like it, but I think it's actually a really, really positive thing for them to kind of have a think about and take away. Is there kind of, do you know, like in terms of how big can we get muscularly? Like what's our natural kind of limits? Is there good data on that at the moment? I know, Greg, you've written quite a lot about this. I know Mike has a lot of views on kind of the fat-free max index. And I know, Greg, you've written about Martin Berkham's model of his kind of the way he's done it. How good are these models? Are people using them in the right way? Are they getting a bit misconstrued and confused? Are they actually helpful? I don't know if, Greg, you want to touch on that first?
Yeah, so, man, I think the most intuitive to me at least is Casey Butt's model. I don't know if his name is pronounced Butt or Butte, but B-U-T-T, so I assume it's Butt. But the way he derived his model is basically he looked at natural bodybuilders and indicators of frame size, height, wrist, and ankle measurements, and then how that then related to their muscularity when they got on stage. So for people with good genetics, that's not necessarily going to tell you what like the hard limit of lean body mass is, but it'll give you a decent indication. I think the biggest drawback to that model is it probably skews high for most people. Since it is specifically looking at people who were accomplished natural bodybuilders. When you start dealing with more general models that don't attempt to account for frame size at all, like, for example, fat-free mass index, just simply because you're not doing anything to control for that rather large variable, it's going to be much less predictive. Another pretty good one, which unfortunately isn't really accessible for most people, is a guy named Francis Hallway. He has a metric that's muscle to bone ratio. And so that's wet weight of muscle, not dry weight of muscle. If it was dry weight of muscle, you could get it from DEXA and it would be super easy. But the problem with that is to estimate wet weight of bone. I mean, to estimate wet weight of bone, you need to get like 27 measurements taken by an anthropometrist, like to get a good estimate of that. And the estimates they can produce for wet weight of bone are actually pretty good. Validating them against cadaver data, like they correlate very, very strongly. But anyway, you're not going to be able to take those measurements yourself. But he's found that that's actually been quite predictive. Looking at elite athletes from a lot of different disciplines, finding that most of the time, people without drugs can get up to about a 5-to-1 muscle to bone ratio, with some people getting up in the 5.5-ish to 1 range. But past about 5.5 pounds or kilos of muscle per pound or kilo of bone, past that, most drug-free athletes just aren't going to get there. So, and that's another thing. Like, I think kind of like Casey Butt's model that does account for frame size explicitly in this case, because it's estimating bone weight. So I think that ones that estimate frame size to some degree still have their issues, but are generally going to be more accurate than something like fat-free mass index, which can't and doesn't do anything to account for frame size whatsoever.
Awesome.
Mike,
yeah, go for it.
So that's all. So when we talk about the kind of models that best predict what I guess can be termed as peak muscularity, I suppose that what we're trying to predict here is, given all possible inputs short of anabolic draw, how large of muscles can an individual or certain parameters develop. And what is really helpful in understanding how these models work and how every single kind of these models can and will work is they work like many things on a statistical basis. So what they're telling you is it is a certain percent unlikely that someone over X amount of muscularity is drug-free. But they can never tell you that it is certainly not the case. So problem number one that all models like this, I don't say miss, but just don't have the power to delineate, is there's a huge amount of genetic variation. And like Greg said, most of it is relatively uninteresting because most people average. But these discussions don't normally come up for average people of who's on drugs and who's not. They come up for non-average people. Take the perspective of Big Ramy for a second. Big Ramy is currently, actually, from what I've heard, 345 pounds with abs and veins, which is pure fucking nonsense, by the way. If you think. No, I know. There's pictures. It doesn't look like a human being anymore. It doesn't look like anything anymore. It looks like a giant question mark. Might as well do that. So, if him, with his genetics, let's assume he has even a way above average response to drugs. And let's assume he's shooting drugs to the moon, which maybe he is. That still, if he was 245 pounds at the end of a productive 10-year natural training cycle, would it surprise? No, it wouldn't fucking surprise. You get 100 fucking pounds of muscle out of drugs, and holy fuck, that's a lot. So now a 205-pound person at his height, it beats almost all the models. Now, what do I mean by beats? He's on the very tail end of a distribution. He's maybe 3 standard deviations out. But with 6 or 7 billion people, you're going to find individuals that are 4 or 5 standard deviations out sort of routinely, in a sense, meaning every couple of years they may float up. And so the way, when you're on Reddit or whatever, and people have a thread like, is this guy natty or not? The way you're supposed to couch your views on it is in probabilities. So if you know nothing about an individual and there are 4 standard deviations outside the natty limit, you can say, quote, it is exceedingly unlikely that that individual is drug-free. But I reserve that there is a possibility that they're in fact drug-free, right? And if they're 1 standard deviation out, you say it is quite likely that they are drug-free, but a little bit more likely that they are not drug-free. If they're right in the middle of the distribution as to what we consider maximum development, it's a 50-50 chance. And then another thing to say is, so that's talking about super jack people. Another thing to say for individuals, and this is a little bit more on the maybe not depressing end, but sort of not enlightening end. I think a lot of people tend to start to really shift and shuffle their training and really have this sort of ontological shock about what am I doing wrong when they're like 20 muscle pounds away from the natty limit and they've been training for 7 years and they're just not getting there seemingly. Well, again, if the distribution comes to fuck us all in the ass. That's the peak muscularity for humans. Usually they don't put those numbers at average well-developed muscularity. They put that automatically. So here's the average distribution mean. That model predictor is already 2 standard deviations out. And so if you're just average in muscular development proclivity, you'll probably never reach, and whatever the fuck FFMI 25, whatever that shit is, Greg could be more assertive with, whatever Casey Butts model, that sort of whatever that amount is for height, etc. Most people won't reach that, even if they do everything they can, because most people don't have amazing genetics. People have misinterpreted the FFMI 25 thing to be like, well, I'm still off my natty limit, so there's no point for me to switch to drugs, or there's no point this and that, or maybe I'm doing something wrong because my natty limit's so far off. Like, you may be at your own limit way before you reach the natty limit. The natty limit is for the human population. But Greg, what is it? 2 standard deviations above the mean of muscularity, or 3, or something like that? Like, it's already special people.
It's like 2.3 or something.
That's like, that's like 99% of all people straight up never going to be that muscular. So if you're like, just to abuse FFMI for a bit, if you're a fat-free mass index of 19 and it's supposed to be anything above 25s on drugs, but up to 25 you're a good moral American, you vote and pay your taxes. Then in the United Kingdom you're all immoral fucks anyway, so isn't that included? But so if you have an FFMI of 19 and you're like, what am I doing wrong? The answer could be you did everything right and you're just reaching the peak of your muscularity, and there's nothing surprising about it. It's like saying, just about the fastest that fast humans can run is about 11 seconds in 100 meters. Now, there's some people who run faster than that, but 11 seconds is damn good. Can you imagine the average person training and being like, shit, I'm still at a 13.1. What am I doing wrong? Motherfucker, almost no one ever runs at 11. That's not what you're going to achieve. That's incredible. So I think some people just take for granted they're going to achieve incredible and then needlessly program shift or do a variety of other things when that number doesn't come. And I think there's something to be said for that, as well as for the freak side of the equation.
No, I think that's super interesting. And that comparison and idea that you gave across is fantastic, because I think a lot of people can relate to that, and they can, there's fast people and there's people that you're never going to be as fast as that. But people, for whatever reason with muscularity, are like, they have their eyes set on a prize and they're like, I'm going to get there eventually. Where's this silver bullet? I'm going to find it. Something I did want to touch on, because we've talked about kind of...
If I can just
go for it.
For a little bit. Something I like that you brought up, Mike, is that yes, if people tend to use like the idea of like a quote unquote natty limit wrong on both sides of the equation. One, everyone and their brother thinking that that's like their goal that they should shoot for. It's not a bad goal, but based on how the models were derived, it's probably not somewhere that the vast majority of people are going to get in the first place. And then on the other end, if people are trying to use it like as a way to predict if someone's on drug tests, like I agree 100% that should be addressed instead of just a hard cutoff probabilistically. And incidentally, since I love Excel, I made a spreadsheet based on like the published research data on fat-free mass indices of users and non-users, as a way to get an idea of the odds that someone is drug-free based on their fat-free mass index. And I was hoping it would catch on, because as far as I'm aware, it's like the most statistically rigorous way to go about answering this question. But I also don't think anyone understood it, so it didn't. But we can put that in. I never saw it, Greg.
I'm now curious. Please do.
Do what?
I never saw it, man. I'm really curious to see it. Please put it in the show notes, because I want to take a look at it.
I mean, it's really simple. Like, it's just like you take the means and standard deviations for users and non-users, like plot those probability probability distributions, and then like I also have a way that it can account for your assumptions about the percentage of a population that's on drugs, because we can't forget about base rate neglect here, guys. This is another thing that, like, this is way off in the weeds, but it drives me crazy when people have this discussion. So essentially, like, if you assume the quote unquote natty limit for fat-free mass index is 25 or something, and you come across someone who has a fat-free mass index of 25 and a half, and you want to assess the probability that they're on drugs or not. One thing you have to keep in mind is what percentage of the population you're dealing with is on drugs or not. So for example, if that's like a NPC bodybuilder or something like that, untested bodybuilding, you assume 95% plus of those guys are on gear. So if you come across an NPC bodybuilder that has a fat-free mass index of 23, there's probably still a better than 50% chance that that person's on drugs, even though their fat-free mass index is relatively low. If, on the other hand, you're dealing with like an IPF powerlifter who, even if you take like a really cynical assumption and assume that 20% of them are on gear, which is much higher than I assume it is. Even if you think 20% of them are on gear, and you say there's an 80% chance that someone is drug-free in this population you're dealing with, somewhere above the quote-unquote natty limit, odds could still be in their favor that they're drug-free. There could still be a 50% plus chance. So yeah, that's the other. The more classic example of base rate neglect out there is, so if I describe someone to you and I say they're kind of shy, quiet, bookish, their idea of a fun evening is not to like go out to the bar or whatever. They prefer to sit home and curl up by the fire with a nice book. Are odds better that this is a librarian or a factory worker? And also in describing this person, they're a man. So most people, when they first hear that, will say librarian. But the thing to keep in mind is there's like 100 times more male factory workers than male librarians. So even if only 1% of male factory workers meet that description, there's a better chance that that's a factory worker than a librarian. So essentially, the spreadsheet is built to take that into account as well. So you not only plug in what the fat-free mass index is, but also your assumption of base rate of how many users are in the population you're dealing with. And without accounting for that assumption, you really can't get any kind of grasp on the probabilities you're dealing with.
That's super interesting. I think I've seen it. I can't remember it in detail, but I'll certainly link it in the notes below so people can have that. Because I think that sounds really interesting. And I think, people love a natty witch hunt, so why not use something that's actually fairly rigorous in your testing and go with the Excel spreadsheet that you produced. Something I did want to touch on.
I don't mind if people witch hunt. I just prefer they witch hunt in a statistically rigorous way. You know what I mean? Which I feel like it's kind of counter to witch hunts, but whatever.
It's the evidence-based witch hunt. So
it's good empirically driven witch hunt. We have way too few of those.
What I wanted to bring up was you talked about in Casey Butt's model, kind of talking about bones and structures, and I think I've heard Menno Henselman talking about it as well, where it's like he talks about it in relation to it's your foundation. The bigger the foundation you've got, the more ability you have to build upon that foundation. So like a house, if it has a big foundation, you can build a really big house. If you've got big bones, big wrists, big ankles, you have the potential to build more muscle upon those. That sounds awfully similar to like a mesomorph, ectomorph, that sort of thing. Is there any reasoning behind this? I know as a lot of the listeners will know, these aren't particularly great models, but they do have some similarities within that. I don't know if Mike particularly wanted to touch on those sort of models and their predictors and whether people can be one or the other, or if there's any genetic kind of individualization within those.
I'd love to start that one off. The classic body typing model missed one kind of body type in their search for extremities of body types, and that is the skinny fat hipster, which is a modern body type, but I'm sure had to be around back then when they made these things up. So we can take a look at just two primary variables. Let's keep bone structure out of this for just a second. Let's imagine that a mesoendoectomorph is based on two variables and their intersection, muscularity and leanness. So someone with a lot of muscle and not a lot of fat would be a mesomorph. Someone with a lot of both would be an endomorph. And someone with not a lot of fat but also not a lot of muscle is going to be an ectomorph. They left out the skinny fat hipster, which has lots of fat but not a lot of muscle and looks great in one of those flannel shirts with a top button buttoned and skinny jeans I'll never be able to wear. So that's the thing, is that if you're going to look at those two intersecting variables, you have to remember that there's 6 or 4 peaks to it, right? Not 3. And it's one of those things. It's kind of almost like a tragedy when someone is like, because the way they describe endomorph, for example, um, somebody who had plenty of body fat, big sort of big wide bones, but put on a ton of muscle and strength. And that left out a bunch of sad motherfuckers that had these tiny frames and a shitload of fat on them and not a lot of muscle building proclivity or base rate to begin with, or base size. And what the fuck? They were like, oh yeah, I'm an endomorph. And 2 years of training later, they don't have shit to show for it. And they're like, I'm not going to be a lumberjack, apparently, like this model said I was supposed to be. Now, I know I'm not going to be Mr. Baywatch, mesomorph guy. I know I'm not going to be champion endurance runner, actomorph guy, but damn it, I thought I was going to be big and strong and at the very least hairy. It's one of those things that it just misses one fourth of the potential population. And then when we expand our view and say, okay, well, so if we got the 1/4, and really it's just a spectrum of muscularity and body fat, then we can put in a spectrum of bone size into there and frame size, and that makes the model much more complex, takes our 3 or 4 different body types and makes them damn near fucking useless, because now there's this really, now we have like instead of a square, we have like a fucking octagon or something. It starts to look like a circle of variation. We can put in there, I would go so far as to say that, you can put in a bunch of stuff. So for example, there's a difference between bone cross-sectional area and bone length. Individuals vary on that. There's a difference between muscle attachment site width and actual bone width. There's also a difference in which part of your body is big. Some people have relatively narrow interacromial space or interacromial width. The shoulders are narrow, but they have really wide hips. Some people have the other way around. Some people have wide both. Some people have narrow both. So once you start talking about it like this, you really just these 3 body types, sort of really old mesomorph, endomorph, ectomorph, just become a fucking total waste of time. And the only question you have to pose for yourself is, what is my proclivity to gain muscle, and what is my initial state? What is my proclivity to gain or lose body fat? What is my initial state? In the multiple parameters in which they are variable, what is my proclivity to have the frame size to potentially carry even more muscle, etc.? And then after that, it's all said and done. It looks like a pretty complicated soup to mix up. And I would say that it's probably best not to really look at that soup too much unless you're really into this kind of stuff like Greg and I, and you're just doing it for intellectual curiosity. Rather just to throw your dice in, see how you do, because that shit all sorts itself out. It's interesting looking at stuff, but you can't change any of this unless you're working on a super advanced genetic shit, which in RP we always are. We'll be producing fake humans in no time. You can just have your own surrogate, and they're farmed and they have this pretend life they think they're living, and then they're killed so you can have their body. But anyway, it's a nice life they have. So I'm getting off track, but in any case, it's one of those things like, it's not just like the 2 variable, the 3 body types. It's an infinite number of body types, and because there's so many variables determining muscularity and body fat distribution, there's another one. I just made another one up. Body fat distribution. Like, do you have a lot of upper body fat or lower body fat, et cetera? Which one are you? Meso, endo, ecto? What the fuck is that, right? So it's much more complex, but in some sense it's much more simple, because it really is muscularity versus leanness and body shape, and which type you are is really kind of a fucking point of a question to ask.
And another thing I'll add about somatotyping is it was never meant to say anything about like trainability or bodybuilding or strength training or anything like that in the first place. It was a crackpot psychology theory. The idea was that you could body type people, and if someone was an ectomorph, they were going to be like shy and nervous. If someone was a mesomorph, they were going to be a bold adventurer and highly intelligent.
Because they beat everyone up all the time.
Yeah. And if someone was a endomorph, I think they were stereotyped as like lazy and stupid, which that stereotype has continued to carry over to the modern day. Anyway, but yeah, it was all just like a crackpot psychological theory. It had nothing to do with strength training in the first place. But the book, like, that really popularized it, the Atlas of Man, dropped in 1954, I believe, when like the whole bodybuilding, like physical culture was taking off in the first place. And so that got like picked up by that movement and like pre-Golden Age bodybuilders, and it's just stuck around ever since. Yeah, that was never what the application was supposed to be. Like, it's just crackpot, stupid psychology.
Yeah, I think I mean, people know it now as something it's making a gross simplification out of things. And actually it's less helpful than it actually ever kind of could be. And I just want to make sure you guys, I definitely want to get you on again, but I know you both are busy. So should we call it here? We've had like a nice introduction about kind of muscular limits, talking about kind of genetic proclivities to muscle growth, and how kind of we can have fast, slow burners, and kind of, I loved Mike's comment there about we should just kind of chuck in the dice and there we go and give it a good try. But I definitely think we have a lot more we could delve into. So I want to thank you both for taking the time now. And sorry that it got cut a bit short. Sorry to the viewers that it got a bit short, because I know we were just getting into things. And I want to definitely get you on again. So yeah, thank you so much for coming on. And I'll make sure everything we talked about is in the show notes. Everything that people can contact you will be in the show notes as well. And hopefully we can catch up soon.
Yeah, thanks for having me, Steve.
Thanks for having us, and hopefully we'll both be back at some point to keep hashing.
Definitely.